solid code, interface segregation principle, Mr. Singh. Cool. All right, so we have an interface called doors. And you can lock a door, you can unlock a door, and you can check to see if the door is open. Pretty simple. What's that look for? Okay.
What happens if I lock an open door?
Don't worry about it.
Okay.
All right. Let's assume that we have...
The testers will find it.
Yeah.
Eventually.
In 3 years,
Not right off.
the testers will find it. So let's assume that we have a door that is like some sort of security door, and if left open for like some set of time, it needs to sound an alarm. So we have a timer class and a timer client, and the idea is that a timer client can register with the timer class an instance of itself and just say how long it needs to like take before it gets a notification. So the timer takes the client and then will notify the client when the timeout has been reached, and there's just this timeout call that the timer will call for you. So we kind of need to make a door that does all these things. So how do we make a timed door? Any ideas on how we might want to put this all together? Not all at once, please.
I mean, the door needs to have a timer client.
Needs to have a timer client? Okay. So
when it pings and says timeout, it shuts.
The door could have a timer client and manage its lifetime, or it could be a timer client.
right. So yes, those are basically the two big options that we will cover. We'll cover this one first, which is that door can be a timer client. So the idea is, okay, well, time door has to be a door, but then to be able to be a time door, timer client needs to show up in there somewhere. So we'll just throw it on top of timer client in case there's other sort of timed doors that we need in the future, right? So how do we feel about this overall?
That whole door has been timed.
Exactly.
You anticipated that.
Impressive.
Yeah, no Karnak.
Yeah. Okay, so not all doors are timed doors or have timers, right? So what does that mean necessarily?
We shouldn't forcibly pair them together like this.
Right.
So we're adding like an unnecessary dependency or something.
Right, I mean, the timer client shouldn't have to be a property of a door.
Yeah.
Member variable or whatever, or door derived from the timer client.
Yeah. Yeah, so this is really looking at the implementation side of it and going, oh, well, I can just throw this extra class in here and it solves my problem. But,
Have
you
you
know,
been here long?
you know.
Well, are you trying to show, are you showing an inheritance relationship
Yes.
between time door and door?
Yes, this is a UML 1.0 diagram
Okay.
from
But
1996.
then, from the door to the timed client, is that an inheritance relationship?
Yeah, so time door inherits door and door inherits timer client.
I mean, that's one way of doing it, so that's what you were representing there, right?
Yeah, yeah. There's two options, and I'm intentionally picking this one first. I think the awkward feeling you're having right now is intentional. I hope you have an awkward feeling.
Yeah, well, I'm trying to understand, so that's the inheritance scheme, and so it's not multiple inheritance, you're showing
right.
single inheritance. Well, I'm not too happy with the inheritance scheme.
Yeah. So one reason why we shouldn't be too happy with that inheritance scheme is because not all doors need timing.
Right.
So we've lobbed an extra responsibility into a type that has no concern with it whatsoever. So that would be one reason why we don't feel good about it. What other reasons might there be?
Yes, so would help.
Well,
If this is the I section of your solid talk.
Oh, okay.
You could SO it.
Yeah.
to me, it's not an is-a relationship. If you want a has-a, then the thing, at least it would be multiply inherit behavior from more than one thing.
Yeah, yeah, that's the other option that we
Yeah,
had
that's
mentioned.
the other, and that still doesn't.
Who mentioned that?
I think Sean or
Sean.
Sam.
Okay, I didn't pick up on
I
that.
forget, okay, probably Sean, whatever.
But even so, even if it has, if a door has a timer client, it's still the same problem. Not all doors have timers.
If the door
No,
is holding,
but
yeah, right.
All time doors are going to have a timer client.
Right. It makes sense from the perspective of the time door to eventually somehow inherit from timer client because it needs to interact with the timer.
Right.
But other nodes off of the door don't necessarily care about this timer client, so
Right.
that's a problem. So to Rob's point of the other letters in solid, we would have to define a default null implementation of the timer client, so that way any other implementations of door that don't care about it can still inherit from door without having to be worried about implementing some timeout function that it doesn't care about.
And I just picture somebody like Rudy or something, it's like, then they just don't need to use it.
Yeah, and I mean, there is that. That's why I say probable LSP violation there. If you recall from the LSP talk, the violations of the of the list cost substitution principle are defined by like the requirements of what is needed out of it. So it might be okay, and it might not be the worst thing ever, but you still need to keep in mind that you might be violating the LSP. It's kind of the key there. With all of these principles, there's no like hard yes or no thing here. And then also that each new behavior that you want to add to doors, so if you have a different derivative that also needs a different interface here, and then you've got more either out this way or further up, you have more dependencies that you're throwing into door that make it very hard to extend the behavior of new doors without changing the implementation of door if you were to continue this design. Because every time you have some new dependency, for some reason the precedence has been to throw it into the door interface instead of the actual like, derivative that's implementing door. So yeah, so I think we got it. Good job, Ron. Oh, one more. Okay, yeah, so then the other big problem as well is that any change to timer client affects all clients and implementers of door. So we've added this extra dependency, and one of the big consequences of that is that we might not care about timer client changes, but we are now victims of it because it's in there. So I'll talk a little bit more about that. So the interesting thing, this is probably the most interesting point that when reading about ISP is made, is that clients actually apply backward force onto the interfaces that they use. So each client has a certain requirement on the interface it's using, and the more clients you have on an interface, the more pressure there is to not change that interface, or the more effects you have if you do change the interface. So one would say that that makes the interface more stable, the more users of it has.
And changes in it more risky.
Right. So the problem is that anytime you have an interface that contains more behavior than a client, any particular client cares about, then now if like client 1 is using things out of this fat interface that also contain things necessary for these other clients, but it only needs a smaller set of that, then suddenly client 2 has some need to change that affects the fat interface, and now client 1 is innocently affected by it just because it's trying to use the thing that had the functions that it needed to call or whatever.
It's like, the fat you want to use the right tool for the right job.
Mm-hmm.
But now you get this, the fat interface becomes like the Swiss Army knife that has all these different things on it.
Yeah.
So you can use it for lots of different things. Lots of people didn't use it, but then if everybody depends on that Swiss Army knife, if you have to change it because somebody else needs something, well, then everybody else has to change.
But it also incentivizes not changing it.
Right, and that's the
Because
whole
it's like a
stability.
very well-defined interface that just don't touch it, just make
Yeah.
a new one.
Yeah, so, right, it's very common in like presentations on ISP to show the picture of a Swiss Army knife, and you've now got like the one thing that does all, actually single responsibility principle, this comes up as well, Whereas now you might have like a Swiss Army knife with all these features, but we just need to use that one, and we need to come up with a way of just taking that tool out for a moment and only having to deal with that. And for, yeah, your point is that with increased stability, where stability is defined by the number of, or the amount of fan into an interface, so how many things are going into that interface, it makes you not want to change it, because the effects of, like, the propagation of those changes now grow. Like, you have to retest more of the system or whatever.
But now that restricts you too.
Right, so the more stable a particular component is, the less likely you are to want to change it, and you'll have to do some other thing that might not necessarily be the best thing, but makes the test risk lower or whatever kind of thing. So it's just an unfortunate result of this, clients depending on more than they need is all of these kind of problems. So just to touch on one point that, but okay, whatever, so it's just a rebuild. Luckily, I think we attacked this pretty quickly already. But the other point, which was related to what I just said, is that the longer the build times are, because that's like the simplest or easiest to see problem, is that, okay, I have to change this interface, which means a couple more things than I was expecting need to rebuild, but it's just a rebuild. But the instant those builds start taking longer and longer, the more developers are going to be likely to not want to make those changes, and they'll start plopping code in the wrong place because that place takes less time to build than the correct place.
You've seen our code.
Exactly. So that they're just like little paper cuts over time that grow into like huge problems, and you let out onto the floor by the time it's all over. So, and then yeah, also it affects independent developability and deployability. So if you have fat interfaces, then you might have different teams responsible for each client, and now they want to change fat interface, but this team is very, no, you can't do that kind of thing. And then also, if you were to change an interface, then you have to worry about versioning if you were to deploy these things independently without having to affect the other client. And then same thing for test isolation, is that the more things that get affected, the more have to be tested, or should be tested. Okay, so to finally formally define interface segregation principle, we should say that clients should not be forced to depend on interfaces that they do not use, or parts of an interface that they don't use, I guess. Okay, so here's what we can do rather than the tree of inheritance, or the deep inherited structure, is that we can take an adapter class that now provides the timer client interface, but it's specific to doors, or it's a timer for the door specifically. So the adapter knows about the timed door, and the timed door, it knows about the interface of timed door, so that way it can map from one to the other. And timed door just instantiates the adapter and only implements door. So now you have a whole separate object that's providing that interface, and so that they don't need to know about each other as directly. One way to do it. Any comments?
Well, my first thought is we, years ago or whatever, probably would have just, if we'd gone beyond what you showed before, we would have just taken a timer client and put it in a time door, not have the adapter. So I should know by now, but what does the door timer adapter buy you?
I assume this was made for, never mind.
Extensibility, I assume? Because there are going to be a bunch of different timer clients, and they might need to be specific to whatever their time. So you just add another layer of specification on top of the timer client, so it's more tailored for a door.
Yeah.
Couldn't you do like multiple inheritance kind of thing, where a timed door is a door but has a timer client?
We can certainly do that on another slide. But in terms of this,
I like to do it through delegation.
Yeah.
Maybe that's a bad thing, but I like it.
no, there's nothing wrong with it. It's just, well, all right, whatever. We'll get to it.
Okay.
I don't like to talk too much ahead of where we're at. So yeah, what Sam said is true that you can have different types of adapters now. It does give you that flexibility that you've now isolated the idea of something that bridges between the timer client and the time door, so that you could provide, if for whatever reason you had some different idea of how that should be adapted between the two, you can have that isolated in a family tree of adapters. So you do get that out of it.
What's the white diamond represent?
It's composition. So you just, I think it's composition. I don't know. It's UML 1.0, and they had lots of symbols for things. I don't remember exactly what it is, but
So you're saying that timed door has a
yeah,
timer?
yeah, right. It's just the time door has an object as a data member called door timer adapter.
And then the dotted arrow.
Is a uses relationship, so not only does it have it, but it also uses it, I guess. I don't know, whatever. UML diagrams used to be more complicated than people bother anymore. I just didn't feel like redrawing it. So, yeah, so either way, the advantage here is that users of Door no longer need to worry about a timer client. That's all just isolated. Door is over here, and timer client's in its own world, and it just happens that time Door can bring, or can bridge into that world. Door timer, which is the adapter, just translates, which I said earlier, the timer client to the door interface, or specifically the time door interface. And the one downside is that there's just an extra class. You have to say door timer as a class, and then you have to either instantiate it or take it into as a constructor or something, and that way, you've got an extra allocation and you have to define another class. So there's a little bit more work involved in getting that set up. So, that. What other techniques might we do? What did that mean? Okay. We could use multiple inheritance. Okay, yeah, so this is a much simpler idea, but it actually accomplishes the same goal, that anyone who's holding on to a door can use time door without knowing about it, and anything that needs a timer client can to use a time door and not know. So the timer class who's looking for a timer client can be sent an instance of time door because it implements the timer client interface, and anyone who wants to open a door or lock a door can be given a time door without knowing any better. So all the clients are isolated to only the parts that they care about, and changes to timer client don't affect clients of door. Pretty cool. So there you go, vice versa. The other advantage over the previous option is that we don't need the extra class, we don't need the extra allocation and hold a data member and all that stuff. We just implement all the interfaces in a single class. So then that brings us to, okay, why would we pick this over the other, or vice versa? And this is kind of the preferred way just because of its simplicity. Not to say that that makes it any better, it's just simpler, easier to implement. The reason you would pick delegation is any time that these interfaces kind of conflict with each other enough that it would make implementing time door difficult or awkward, you'd want to do the delegation because you get this separate thing that has to worry about that awkwardness. So you're isolating the awkwardness into one place so that time door kind of looks the way you want it to look and not need to worry about all that.
So we go back.
Sorry.
Yeah. So if for some reason door and timer class or timer client had, the same interface name or something,
So that a function with the same name
would conflict, and therefore, but you wanted the door version of it, you didn't want the timer client version of it, then you use the door timer adapter just to kind of mask that off.
Right. Yeah, so you could, any explicit conflicts in the names of the functions can be dealt with an adapter rather than implementing both at the same time, because that gets a little nasty.
In your multiple inheritance, did you show timer client? Okay, you didn't show it as an abstract class.
Yeah, I don't know why it got dropped abstract there.
Because that puts a little more of an onus on time door. It has to override any, if it's abstract, it has some pure virtual functions, and it has to override them.
Yeah, I think before you got here, we showed the timer client interface, and it has an abstract timeout function, or a pure virtual timeout function. So you have to implement, we saw that door has a lock, unlock, and is opened, and timer client has a timeout function, so you have to obviously have all of those in timed door. One note actually on that point is, I mentioned in the single responsibility talk that sometimes, although we like to have, or we should prefer having classes broken down by the responsibilities, sometimes it's just easiest and makes the most sense, and the best maintainable solution is to just put a couple of responsibilities in a single class. This is sort of a concession to that. That we have multiple responsibilities of being a door and a timer client, but it just so happens that it might be easiest to do it that way. And the benefit of the interface segregation principle, or doing it something like this, would be that the clients of the interfaces don't know that. So they're isolated from the knowledge that the implementation has multiple responsibilities. So they only look at the interface representing each responsibility. I don't know if I wrote that down on another slide. This might be it.
Yeah, it might be worth noting that depending on how you do it, when you do implement a timer client like this, with the multiple inheritance trick, it's now important that you make sure that no other clients are using timer client. If it would be
No other clients or what?
somebody, a client of time to door could conceivably say, hey, you're a timer client, right?
Mm-hmm.
I could call your timer function.
Yeah.
So it would take a certain sort of evil client to do that, but it is possible that somebody could be, I don't know, drunk while reading the documentation or something and call something wrong.
Yeah, that is the downside of these sorts of things. The only solution to that sort of thing, at least in like C++, is that you could make it private and friend only the timer class, but now you've broken up the open-close principle. So yeah, it's one of those, how does Herb say that? Protect against, how does he say that? Malicious versus, or you're not trying to, you know what I'm talking about?
I don't know the phrase, but I know what you're trying to say.
Yeah, it's basically, we want to protect people from accidentally doing the wrong thing, but we're not going to protect you from actively doing the wrong thing. And it could be said that you don't realize that you shouldn't be calling the timeout function, but what are you trying to do? So, yeah, I mean, there are ways to address that, and yeah, it's something to consider. And unfortunately, there are no good ways of considering it, really. It's case by case.
Yeah.
But you said it's worth keeping in mind, so I agree.
Yeah.
Okay. All right, I think this is the last thing. I mean, the ISP is very simple, so there's really not a whole lot to talk about. But the last thing is, which would we prefer? This is called a polyad function or a polyadic function? I don't know. People make up words. Would we rather take interface 1 and 2 in F when we know that the impl class implements both of them, or should we just take the impl class so that way we don't have to take the two parameters? Because now anytime you call F and you have like I as the instance of impl, I don't know why I didn't put that in there, the call would pass I in both parameters, which looks a little goofy. So which do you think we should be preferred here?
I think the impl.
Okay. Why do you think the impl?
Well, my first thought was it's less that you're depending on. You don't have to depend. Your interface only depends on the info, not on phase 1 and phase 2. And then you've got two. You know, if something changes in interface 2, then your thing has to change. Whereas you're isolated more if you're just doing info. But if you're doing info, that sounds like you're gathering potentially too much more than you need, and therefore violating the ISP.
Right. So, for the sake of the camera, the impl class implements these two interfaces, potentially more. So by taking impl as the dependency, yeah, okay, great. It has the two things we need, so we don't need the extra parameter. But at the same time, we've now encoded the knowledge of the fact that impl happens to today implement these two interfaces. But we've also taken on any additional things that happen to be inside of the impl class that we don't care about.
So doing the first one, you're doing, it's closer to a cleaner design in that it only uses what it needs.
Yeah, and to say it another way, it expresses explicitly what it needs. It doesn't need an impl, it needs the two things that impl implements, and it just happens that it implements both of them, and so the caller might have to look like, oh, okay, I guess I'll pass it for both of them or whatever. But at the end of the day, that tells the caller, and especially a programmer who might not know what F does or all of the details of F, it tells the caller that, oh, well, F needs these two interfaces, not that it just needs this giant class that 10 years ago was a lot lighter weight but has since grown over time. The likelihood that those interfaces grow is less than the whole implementation class.
Right. I mean, you run into the risk then that the function F, might have to change. And then because you encoded the fact that you expressed the fact that you need these two interfaces, if you change F enough that you need something else, a different interface, then you have to change F and its interface and then rebuild everybody.
Right.
Whereas if you added Nimble and Nimble had the other one, then you could change F, use the new thing without affecting everybody. But,
Right.
So here would be my thought process when picking between one or the other. If F depends on impl being a single thing,
Yeah.
then it makes sense for it to be that single thing. Because you could conceivably have iFace1 and iFace2 be two separate objects, and F could get very confused when it makes changes to iFace1 and they don't appear on iFace2 because
Right.
they're different objects.
Yeah.
So in that sense, you're baking in the invariance that they are the same thing in the second caller. And that might be the correct choice, even if it does drag along some extra stuff with it.
because it depends on what impl really is.
Yeah, so that's a really good point. And I'll say it again a little louder because that camera has a hard time picking these things up. So if F depends on the idea that impl is a single object, then, or even the other way around as well, that if these two things are expected to be separate objects, then you want to pass them that way or be able to pass them that way.
But if interface 1 and interface 2 are always together, then
Yeah.
put them in and impl in one object that represents the thing that it really needs more correctly.
Right, and an alternative to that would also be that you could define an iFace3 that composes both iFace1 and 2. That might be a maybe better alternative to express that, okay, well, sometimes clients need these things to be together as one object, kind of thing. More often than not, you want to try to take dependencies on abstract types rather than concrete implementations anyway. So if it just so happens that impl does implement these two and you need them together, it would be better off to make an iFace3 that takes 1 and 2, and now impl can implement that iFace3, but that way you don't force the concrete implementation if you don't need it. Again, preference. So it's not always the case, but you want to prefer depending on abstract types when you can. So that would be one thing that you could do. Okay, see if we caught it all. Yeah, so, right, so we're encoding the knowledge that the implementation just happens to have both interfaces, and now any change to impl affects F as well. So we've kind of increased coupling because we have that implementation dependency rather than an abstract dependency.
Assuming that impl is more than just iFace 1 and 2.
Yeah, right. Yeah, yeah, right. Okay, so this is also an example of that backward force, that the client, which would be F here, is putting a force on the interfaces and saying that, like, if I were to take impl here, I'm putting a stronger force on the assumption of how things are implemented. Whereas if we do it here, we've reduced the amount of pressure on the interfaces because we've focused down into just the interfaces that we intend to use rather than the knowledge that this thing must implement both. So it gives us more flexibility in the implementation of impl to not necessarily implement both of those things. Okay, that's all for the traditional interface segregation principle. So let's do like a quick comments, concerns, questions.
Do we have a wrap up of go back over SOLI, you know, where we are so far, you know, just a summary of.
Yeah, I was planning on doing that with D. We don't have the one left, so.
Yeah, that's fine.
Yeah.
So somebody has to say it, even though it wasn't called the interface segregation principle, the component object model strongly hints that this is how you should be designing your interfaces
Right.
and components.
Yep.
Um,
Yeah, COM happens to follow a lot of the solid principles. I think we mentioned that when we were talking about the single responsibility. Actually, it was kind of in the context of we mentioned giving multiple interfaces, which is more to the interface segregation principle. Yeah.
I'd go as far as to say that it almost enforces it, in that when you call a co-create instance, you get an interface out of it. You don't.
Yeah, you don't know
an
who-
instance.
right. Yeah, you don't really ever know
Yep.
the implementation of a COM interface. So, yeah. Okay. Anything else? We move on? No? Yes.
Yeah, that object can have, of course, many interfaces,
Right.
and you could query for them, but you don't implicitly know about.
Right. Yeah, so that's a good point, that you have no idea that you're looking at a larger object that has more functions inside of it, because you're only looking with blinders on at that interface. You can query interface across the tree. The problem is that becomes, to touch on the other points, that would be an open-close principle violation. That, right? Or is that a list-off substitution? Let's go with both. The two are so close. Yeah, either way, it would violate the other solid principles of trying to jump from one thing to the other, but you can if you need to. It's a concession of engineering, I guess. Cool. Okay, so while building these slides 20 minutes ago, this actually by now an hour ago, it reminded me of a blog post I read from a Microsoft engineer probably 2 years ago, that had an interesting quote that I kind of went wild with at one point. So I just kind of wanted to introduce it because I feel like it's related to this idea of clients putting this backward force on the interfaces that they use and how to think about things in terms of how. Well, let's just go to the quote. I don't know where. Okay, so another way of saying this, which don't worry about what else is said, is that we can write the interface that you wish was available for the application to use. In other words, what is the simple and straightforward interface that would make developing the application code simple and fun? So the idea is that often we touched on this, that often you have an interface that's already there, and there's friction in using it because it doesn't fit perfectly with what you want today or what you need right here, right now. And so now suddenly your code inflates, and because it's constantly dealing with this friction or this impedance mismatch between what you want to do and what this interface lets you do. So you end up with a lot of extra code, and then the more dependencies you have that are all with this, or that all come with their own levels of friction, you end up with more and more code. So something that could be just a simple 3 or 4 lines of code becomes like 50 or 60 or more, just because it's dealing with, oh, well, okay, this interface doesn't quite do what I need, so I have to go run off and do these 4 other things first, and yada, yada, yada. So instead...
Then you have to propose it.
Yeah, well, I mean, it happens everywhere, and this is a pretty new talk, or a new post from 2014, so these are somewhat new ideas. But rather than dealing with those interfaces, if you instead just carved out a new interface and said, okay, if I need to just represent this business logic right here, what interface would make that the cleanest and simplest business logic code possible? So when you read it, it just is the business logic, and then everything else is just details behind that interface.
So it makes the local code cleaner, better, in that the local code now calls the interface that you wanted.
Right.
And then the difficulty then is pushed off onto that, implementing that in some way to make it work. But that's isolating it, so it's not making an 800-line function that, you have to figure out everything. It's isolated there. It's a little more maintainable.
Yeah, the goal would be to, okay, so the applications exist to satisfy business requirements, right? So business logic is the most critical thing that an application can implement, because that's why it exists. All the other things that it needs to do to implement the business logic are details, right? So to be able to separate those ideas, to say, here are the details of how I did it, and here's what I'm doing. And that what is the business rule or rules that you want someone to be able to easily see, and ideally keep it away from those details, so that way if the details change, it doesn't affect the core business logic. So that's kind of the idea behind this article. I left the link in there, I'll send the slides out eventually. Which I think I'm backed up, I need to send the other ones too, sorry. Lost my train of thought. Right, so separating them out. And now you can, if you're only interested in what does this thing do, you can see the business rules, and then if you need to change how it does it, it's often an adapter. And that's kind of what we saw with the the delegation option, was that I mentioned if there's a lot of impedance between the interface that you're trying to implement and how you can implement it, you might want to shove that off to an adapter. This is kind of like taking that to an extreme, where you just define the perfect interface that you want and assume everything else is an impedance mismatch that goes into an adapter. So, okay, now this is kind of another article I read a couple years ago, I think by now, yeah, probably, at least a year ago, that hopefully we can open very fast in Microsoft Edge and save tons of battery. Yeah, cool. Let's see. All right, perfect. Okay, so I'm just going to walk through this. I haven't prepared this at all, so I apologize if I'm like all over the place, but I just thought this was a really interesting like example of that post. The original post I was just talking about didn't really have it. It had some examples, but this is like as concrete as you can get. This is written in JavaScript, so I apologize if this is too crazy, but it's got curly braces this time, so hopefully everyone can kind of catch up.
Like a lambda in there?
Yeah, anywhere where you see like function like that, that's a lambda. It's an anonymous function or unnamed function. Yeah, so this is using a web framework that basically says map this route of a URL, so submit / some number for the question ID. We'll call this anonymous function. So we'll get through that now. So we'll just assume that somehow the web server has started to execute this code. And in there are the business rules of like what this thing needs to do when a user submits a question.
You showed this to me before.
I did show you this. I think I also mentioned the other one, but good job.
Maybe.
Yeah, so the idea here is that there's like tons of stuff going on about like going off to some like database repository or something to get the question by ID and doing some string manipulation and going off to these other services to perform some operations, and then we're finally rendering the result. So somewhere in there amongst this mess is the actual business rule, but it's completely hidden behind all of the implementation details. So let's see if we can find the next part. Okay, so this is basically saying the business use case is now depending on all of these things. So we've got this, like, the express.js is the framework that fires the event in the first place. And then we're also relying on this answer service, the email service, the point service, and the question service. So our business use case is now dependent on all of these things, and any changes to them will affect the use case, and worse off, we just saw that the use case is muddled in its implementation by all of these things. Okay, so then we look at this from the business use case needs to be tested, so how would we do that? And we're not going to go into the details, but the gist is that we have to set up all of these stub implementations of each one of the services that the thing's using, and then like set up mock expectations to make sure that all of those things got called and the right things based off of the stubs we created. And so the testing is not simple, is the gist of this. This is a relatively simple case when you think about it as a person. Like the user's just submitting somewhere there's an answer. This is a book, I guess. So the user's submitting this answer, and we just need to make sure that it went through correctly. Yeah, so we need to make sure that that came in. But there's a lot of nonsense going on to make that happen. So, some words and stuff. He mentions that it actually can be worse than what he showed before because there's even more dependencies going on. Actually, there's more code. Hey, Uncle Bob. Okay, so this is, I believe, yeah, so we're going to show the dream code. So this is now the same, this is sort of pseudocode, by the way, but it's the same business rule, but with all the details taken out. So something we can now see exactly what it's doing. And, if the answer to the question is correct, then we want to award points to the users and record the correct answer by user to the question. And then, say, have you answered all the questions? Then congratulations, send them an email. And otherwise, once you're done, respond with the correct answer. And if they got it wrong, then respond with the incorrect answer. So that's now the whole use case. This is something that like a product manager might say, oh, well, now it needs to act differently. Like we don't want to send them an email, we want to do some other thing. Well, now you can see that very quickly and, oh, okay, well, when we submit an answer, we do that, so I need to go off and change that or add a new function or something. So it's much clearer what the business requirements are without all the details. Okay, so welcome to JavaScript. What they do, or what they propose doing, is you give a port. And you may remember in my talk last week when I briefly covered the hexagonal architecture that I had a hexagon with inner area and then little squares around it. Each one of those squares is a port that could then be satisfied with some external code. This is the same idea, just not the same architecture. So the thing here is just that we take each of those different things from the dream code and we just take them as dependencies into the call to the function. So the function, and because we're in JavaScript, we don't need to define what those things actually look like, which kind of sucks for what does award points mean. But in a statically typed language, you could actually say that's a std function that returns something and takes some other parameters or whatever, yada, yada, yada. But once you have all these dependencies in here, the actual implementation looks a whole lot like that dream code. So this is the perfect interface for the business logic, basically, that we saw about the blog post from the Microsoft guy. Makes sense? And now we look at how to test it, and it's a whole lot easier. They take default options, would be like basically a default basic implementation of that port. So you take all of the things that the function is looking for, and you provide just kind of a basic, like, this is good enough. You can pass it into any call, and then you override the ones that you're specifically testing for each case. So you just set up the options, which is really just the port implementation. You pass it into submit answer, and then you can assert some different conditions or whatever. So you can see before we had to set up all the test stubs and set up the mock expectations and do all these things just to do a single test. Whereas here, a single test is about yay big. So there's a bunch of different tests. Okay, here's the default option. So just kind of gives you an idea of, like, we'll just assume that they didn't answer the question correctly and that kind of thing. These are the lambdas. So that's just kind of nulling out the function to say don't do anything. I don't know if there's any more code. What do we see in here? Okay, so this is now revisiting from the whole thing. Before we were only looking at just that single submit answer. Now we're looking at it from the application framework with the actual details back inside of it. But at the end of the day, all you're really doing is making a simple call to submit answer. And this little curly brace introduces the implementation of the port for that function. It's kind of like what we saw in the test code, where this is the curly brace for an object that implements the default behavior. This is now,
What's line 7?
sorry, yeah. Yeah, so now this is an object that implements the production behavior of the port. So now all the details are here along.
Are you saying a port is an actual JavaScript term, or?
It's an architectural term,
Okay.
yeah. So it's just an instance of an object, or here. So this is just creating an anonymous object. You can do that in JavaScript, because there's no types, so who cares? Where was I? Okay, so all the details are here inscribed in the dependencies that the submit answer was asking for, and it's tied in with the application framework dependency, so all of the external details are now in one place, and the business requirement is in the implementation of submit answer all on its own, without having to worry about any of the nuances of how the service works. Because you can provide these lambdas that can do any of the translations between what the business logic expected and what reality we have in the system around the business logic. You look puzzled.
I'm probably just starting with JavaScript.
Okay, well, just ask, do you have a question?
Well, submit answers, you said is taking one object, which then ends at line 25, right?
Yes.
So it contains, on line 8, you're containing 4 things that you've got above that you initialize.
Yeah, so these are just variables. They're basically data members.
And then what's the next thing on 9? Is that
So, okay, so
a function?
So you're vaguely familiar with JSON, right?
Yeah.
So JSON has like you can have integers, strings, arrays, or objects. And objects have keys and then values, where each value can be any of the things I just said, so it's recursive. In JavaScript, you can also have, you can have functions as the value type. So here we're basically kind of using JSON to create an object that has these values in it, and this key named award points, which happens to be a type of lambda. So it's kind of a variable called award points that is a function. So you're actually, it's like defining, it, because there's no types involved, the submit answers function just took a bag of stuff and then did things with it, and now the system will implicitly define the interface based on how submit answer used it, instead of like an upfront declaration of what it needs. And so this is now an implementation that hopefully satisfies the submit answer function. But
so
we are,
if award points is a name of a member of submit answer that happens to be a method, takes 2 functions and does that, where is it called, used, whatever?
inside of submit answer. I can scroll back up. So, duplicate this guy. Hey, where's mine? Okay. Let me go back. Okay. Whoa. All right, hopefully this will be a little bit easier now. So,
okay,
so the submit answer function is looking for an object with all of these things in it.
Right.
And it doesn't say what they look like, it just uses them.
Right, so
And so
there's
the
the award.
use will define how these things can be.
Right, so that 5th thing is award points, which is just a name, which becomes the function that we pass in, and then.
Right. Yeah, so you just have to know that award points, I thought that was just selected, is a function because of the way it's being used that takes these 2 parameters and is awaitable somehow and doesn't seem to return anything.
Okay.
Those are the requirements. This is called duck typing, by the way. Quacks like a duck, it is a duck. So you just have to make something that looks like an award points function based on the call, and then over here you just provide the implementation. So now award points takes 2 parameters, doesn't return anything, but does something. And if we looked up at the default one, I bet you that it would say submit answer equals parenthesis, parenthesis, arrow, bracket, bracket, which is just an empty lambda. Well, I guess it would say parenthesis and then 2 parameters.
Yeah, so you're just defining all of the variables in lambdas or functions that you need to give to submit the answer for it to do its work.
Yeah, so if you, let's look at this a little bit in terms of a statically typed language, C++, Java, C#. Here, submit answer would take an instance of an interface. So you'd say like submit answer port or something, we wanted to call it that. Now that interface would have members that would like a function called answer that returned a value, which would be a string, I think, in this instance. So you have a function that returns string and it's a pure virtual. So anyone that implements the submit answer port has a function called answer that just returns a string. So that's how you would do it normally.
So this is the business logic here in submit answer.
Yeah, this is just the business logic,
Right.
and these are the details that it's looking for. but in the interface that it wants to be able to make it as simple as possible.
Right, so then back on the first tab.
So now over here, this, if we were,
The ugly details, the
Yeah.
implementation.
so in a static language, we had that port interface. We accepted an instance of the interface, so we could have the business logic as simple and direct as possible. And now this part between the curly braces here would be a new class that implements that interface. And here you can just do it all in like inline because of the way JavaScript's written. But you would have a separate class that implements the interface, and then you would pass an instance of that to the submit answer function. It's just doing it all in one go, magically. That make more sense, hopefully.
Mhm.
Cool. I don't know if there's anything else. Okay, that decent diagram just shows you the fact that now, rather than built on top of all of the details, your business use case stands by itself, and there's an interface adapter that happens to, you should have probably put it this way, but the interface adapter depends on all of these things. So he's keeping the details away from the use case, but doing the adapter. I think that's, oh, okay, so he does make a point that that's all well and good, but it kind of sucks to have a giant bag of stuff, and it might make implementing the adapters more complicated.
It's not like the Swiss Army knife, but you're depending on something that does more than necessarily.
Yeah,
you
and
absolutely need.
the assumption is that at the end of the day, there's probably logical groupings in there that you should probably express. That way it makes it easier to reuse some of those things that are logically grouped together. So here you could just say like, okay, here's some data that I need for the request, and then here's some other data, I don't know, and then here's a notification thing, and then the response. So it's a little clearer now that there's like these different pieces of the dependency. And so in a statically typed language, these could be separate interfaces. And now other objects are free to implement those interfaces, or define adapters that implement the interface, and then you can use concrete classes that can provide those implementations. So it gives you a few more options rather than this very rigidly defined interface that is just a giant bag of everything this use case needs. You can start to see like, okay, well, there's some things here that I have a chance of not, let me back up a little bit. When you have that giant bag of dependencies or whatever, the one big interface that does everything, it's hard for something to accidentally implement that, right? Like, it's got everything in there. Everything the use case needs is in one interface, so there's no way that you just have a class laying around that does it. You have to define another one. But if you have, like, either the data thing, there might be a class that already implements something that has all of these functions in it, but it probably doesn't have a send congratulations email to the user. So you can't use that class for if it were all in one interface. But if you define groups of interfaces, you have a better chance that you might find one that implements this part of it. So you don't have to, it reduces the chance that you have to build more adapters. Hopefully that makes sense.
Yeah, I just keep imagining like sysu.h or something.
Yeah. I'm not entirely sure what he's talking about here. Build and test each. Oh, okay. So this is just because you broke it up now, you can test those things in isolation. And then, yeah. So now, because if you recall up above, we had that giant anonymous object. Now it's a little bit smaller because we were able to only tease out the parts that mattered. So we can reuse some of those objects, and now the call is just much simpler. And so he makes a point that more ports means more code, more abstraction. So that's kind of what I was talking about before, that the more you break out those smaller logical groupings, the better chance you have of not having to have all these classes around that makes it like, oh God, what do I have to do? So this is only to show as an extreme example of interface segregation principle that if you, because in the definition we mentioned that you shouldn't depend on anything that you don't use. So then you should always have an interface that allows you to write the code as simply and as beautiful as you want, like what we saw here in the dream code example, right? If you take it to the extreme, you should always be able to write code like this. Is it practical? No, probably not. So I guess the final thought on that is this sort of stuff I think is most useful for those use cases, like when you're defining what the application does. which I showed in the onion architecture, where you have the domain entities that don't really have much knowledge of what the application needs to do, but has the knowledge of what controllers should do, or how CLEs work, or whatever. And then there's use cases around it that define, okay, well, here's how to copy CLVs or instantiate controllers or something. Those use cases are the business cases. They're the requirements of the application. And so that's where you probably want to be able to encode what those requirements look like without having to worry about those details.
Paste macro.
Yeah. Yeah. Everywhere else, I don't think this cost is worth it, but I just thought it was such an interesting way of looking at it, that like, what it would be an interface that's perfect so you could write something this way. What would that look like? Yeah, so that's all I have.
So this is kind of a small step taken to extreme to show how good it could be, but it at least highlights the fact that the principle is good and that you should try to get more towards this than not.
Yeah, obviously, again, it doesn't have to be this extreme, but there are, different levels that you can adjust this knob, slider, knob, whatever, to get this sort of result. So, kind of like, if you start up with the original, you see yourself with the original code, where you've just got a bunch of details, and this isn't even a bad example, obviously, but if you can't even see the business use case amongst all of the details, that's a hint that maybe you should start looking at different interfaces that you can take into the function rather than making all these assumptions. Right. That's all. Questions, comments, concerns?
On the dot.
Wow, look at me go.
I had a question.
Sure.
You talked about, we end up doing things to try to avoid a lengthy build sometimes. I mean, and I know you added some impl classes to Composer.
Yeah.
And that was at least one motivation for doing that.
Yep.
Was that your only motivation, really? I mean, not that that's a bad thing, or did you feel like you were better organizing the behavior, or what was the?
Yeah, I mean, the pain I felt was in the, so to clarify for other people, I got this thing here, I might as well try it. See if there's a diagram. Oh, that's not what I'm looking for. That's closer.
Good thing we have the frost down.
Impl, I get.
Yeah, okay, so this is an example of that. What you can do in C++, because the build time problems are the worst in C++ or C compared to Java or C# or other languages. What you can do is, this doesn't show great, whatever. But assume that the public members, there's a lot there, or at least a decent number. But then there's even more within the implementation, that you've got a bunch of private functions that are needed to implement that public interface. But you don't want to, because you have to put those privates into the header. Anytime the header changes, anyone who includes you has to rebuild. So by stuffing them in the implementation class is hidden from everyone because it's defined inside of the CPP file, and no one includes the CPP file. So now anytime you make changes to the private implementation, as long as you don't touch the public members, then no one has to rebuild.
Okay.
So that does isolate the changes. It's sort of a concrete interface, basically, that we're not defining an abstract interface, but a concrete interface whose implementation is hidden behind the compilation unit. It's called, Herb calls this a compiler firewall. So the big thing was that I was implementing things inside a system view, C system view,
Yeah.
which is huge, and everyone inside of Navigator includes sysview.h. So the instant I needed to add one more function to satisfy something, I had to rebuild all of Navigator, which takes at least a half an hour, at least it used to.
Yeah.
So I got tired of just sneezing on a file and then having to wait a half an hour just to see what it did. So this is one technique that is sort of related to the interface segregation principle, but I don't know how I feel about saying that, but that allows you to isolate the implementation away from clients without necessarily making them depend on an abstract type that might have weird lifetime management issues and things like that. basically, you can see here that that is a weird syntax. Oh, okay, so that's not a stream operator, that's,
No,
it's the two
yeah.
templates, wow, that's weird, okay. So this is just a unique pointer of the implementation, which is forward declared up here, and then you're holding it as just a data member, so the unique pointer is managing the lifetime of the implementation class, and the implementation class is defined in here. So in the constructor of widget, you would actually instantiate the pimple, and then from then on, you just use the pimple object. This is also called the Cheshire Cat idiom. I don't know if I say that right. I'm terrible. Cheshire.
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 I say Cheshire.
Cheshire. Whatever. Where, you know, the cat and whatever, you don't see the eyes and it vanishes. Yeah. But whatever. I don't think that one. Does that answer your question?
Yeah.
I mean, the build times were definitely painful because I did not like making one small change and having to wait a half an hour to see the results. But at the same time, I also knew that I shouldn't be continuing to drop more stuff into this already massive C system view class. So it allowed me to kind of address both issues by keeping all like the field device or the SDIO implementations in their own classes without having to cause rebuilds all over Navigator.
Oh, yeah, and those are both good reasons to do it. I mean, just not adding another 500 lines and 20 more methods to sysview.cpp alone is enough to make me happy.
Yeah, I will say I would probably do it differently today, but that is what it is.
Okay.
I don't think it's a bad way, but it was okay.
I remember when you did it at the time. Yeah, I mean, I put the second pass in our field device, I even forget what it was, field syncing. I just decided to make it a separate component because I just didn't want another 50 classes in Composer.
Yep.
And also with the long-term motivation that you could do that sync without even being Composer.
Mhm.
We never did, but it would have made that possible.
Yep. Side note on the pimple is that we're kind of getting this built into the language now in a abuse of that concept. Modules will allow us to export only portions of a public interface to other components. And so if you happen to encode the details in that same header file, if users are only using the module instead of the header file, they won't have to rebuild if you adjust the private implementation. Which is why Java and C# don't have this problem, is because they are module-based languages, kind of. So they are able to export only certain parts of an implementation of a class without worrying about the details. So I believe that's maybe going to make it into C++ 20.
Who knows?
Maybe.
None of